Question number 10 involves subtracting and adding rational expressions. One of the things I want you to remember from arithmetic is when you are asked to add two fractions together or to subtract two fractions, one of the things you had to make sure of was that the two fractions had the same denominator. It's almost like if you were adding buckets of things together. If I had gallons of gas and quarts of gas, I couldn't add those together until I had the same unit. Well, it's the same in algebra. When you're adding or subtracting, the denominators, which are sort of your unit of measure, have to be the same. So let's look at a couple examples. I'm going to actually break up problem number 10 in a couple different videos. I'm going to do question 10 part A. Please notice this is an expression, not an equation. There's not a right-hand side. We're not solving. Now, I've started with a pretty easy problem simply because the reason I'm calling this easy is that the denominators are already the same. So what I'm going to do is I'm going to write the denominator one time, and I'm going to do all the work with the numerators. First numerator is 6b minus 15. That just kind of comes down for the ride. Now, this minus sign applies to everything in the following numerator. So, this minus sign affects the 5b and makes it a minus 5b. This minus sign affects the negative 7 and makes it a positive 7. It's analogous to multiplying everything in this numerator by a negative 1. Okay, the next thing I'm going to do is I'm going to collect like terms in the numerator. 6b minus 5b is b. Negative 15 plus 7 is a negative 8. I have b squared minus 64 in the denominator. And just like in arithmetic, you needed to make sure at the end of a problem that your answer was in lowest terms. Well, the best way to ensure that an algebraic answer is in lowest terms is to factor the numerator and factor the denominator and then cancel out any common factors. b minus 8 factors as 1 times itself. In the denominator, b squared minus 64 factors as b plus 8 times the quantity b minus 8. And some of you may have wondered why I put that 1 up here. It kind of looks stupid, but it's really important because look what happens. When I cancel out the common factors of b minus 8, notice that my final answer is not b plus 8, but rather 1 over b plus 8. So that's why it was very important to have that 1 on the top. Okay, now let's look at another example. Part B is not quite as easy as Part A for the fact that you're doing a subtraction problem. These two denominators need to be the same. Now, 4y minus 4g is the same as 4 times the quantity y minus g. So I'm going to replace it in its factored form. Now the reason I'm doing that is by factoring this denominator, I think it makes it easy for you to see that this denominator is complete, but this denominator is missing a 4. So to make this denominator look like this one, we're going to multiply this denominator by 4. But what I do downstairs, I have to do upstairs as well to keep the fractions equivalent. Let's pretend you lived in an apartment building. If your downstairs neighbor got new carpeting, you know darn well that you would want new carpeting. So what you do downstairs, you better do upstairs with fractions. Okay, let's continue. My denominator is now the same. 4 times the quantity y minus g. So we work with the numerators. 4 times negative 7y is the opposite of 28y. You with me? This minus sign affects both terms in the following numerator. It's just like distributing a negative 1. Negative 1 times 4y is a minus 4y. Negative 1 times a negative g is a positive g. When I collect like terms in the numerator, I have the opposite of 32y plus g. In the denominator, I have 4 times the quantity y minus g. Now, again, you always try to make sure your answer's in lowest terms, but the numerator is really already factored. In fact, the only thing you could really do with the numerator is either pull out a positive 1 or a negative 1. Personally, I'm just going to put safety nets around it to let me know that it's been factored, it's done, and the safety nets do another thing. They protect you from doing silly canceling. Like some of my students sometimes would say, this 4 goes into this 32. No, it doesn't. By putting safety nets around this whole numerator, I'm letting you know that that's an all or nothing. So I teach my students in class, it's basically take all of me or take none of me when you see expressions involving pluses or minuses. Okay, thank you.